Well, so you have understood the basic fundamentals of pointers. How do we reference it? What is a pointer? What do we store inside it? And then every pointer has a data type. Why do we need a data type for every pointer? And what a particular data type pointer stores in it. Right? So I think till here, it is fairly easy and understood, isn't it? So you would have gone through these kind of information in many books and videos. As it gets further, it gets complex. So let's unwind the complexity with few more examples. Like when does it get complex? Right? So when you're talking about class and a pointer inside a class as a member, that's the next step. And then a pointer of a class itself. Right? So that's how the complexity increases and we lose track of understanding pointers. So let us take an example of what is it being a pointer member inside a class. So for that, I want to relate it with a realistic example of having a large house or a bungalow with multiple rooms in it. Multiple rooms in it. So what does you enter inside, right? So you enter into a room with the first room, right? So with the door. So that has an address. And so you went to the address, so you opened the door. So think the door as your address to get in, right? So with respect to pointers, so you opened a door, which means you referenced an address and got into the data, what is inside that pointer, right? So now you are seeing with integer I pointer, if you reference star IPTR, you are referencing the value inside the address. So likewise, what happens in case of a class? So class, imagine now it's a sequence of rooms. It's a sequence of rooms that I'm showing you an example. So you have multiple rooms. So you know the starting address. You know the starting address. Therefore, you got inside. And now, how do you get into the second room? How do you get into the second room? You need fill an address of that second room. So where do you store? So unless you get into the first room, you cannot get into the second room, right? That is clear. So because the house is locked with the main door, and you got the starting pointer address, and you got into it, and in order to get into second room, you need the address of the second room, that is the door to the second room. So how do you point it? It is the first node itself, that is your first room itself. As you get in, you see four sides. You have the room that you, the door that you got into, and then there should be another door to get into the second room, right? So which means your room, you think it as a one class or one structure in C, one class in C++. So that has to have a address to the next door, that is room to the next door. So you have some activity to do in that room. So if you take gaming, right? So you have that room, you have to collect some cash, collect some money, and then move on to the next room to find out what is there inside it. So exploring rooms as a game. Now how do you declare that class as a programmer? So you have a class room, right? You have a class room, and then inside it you have an integer to collect money. So you collect that money, right? And then you should have an address to the next room. Only then you can get into the next room. So this is a simplification of your class having a pointer member. Hope you have understood till here. Now let's see, how do we actually use this? How do we actually use this? Right? So here, this is the declaration. This is the structure. How we reference it. Hope you understand this part. This is very important. If you don't get it, do let me know. Leave your comment so that I get back to you. So this is the main room, the structure, how you want to organize everything. So every room has an integer which lets you collect money, and every room has a next room, door to the next room. If there is nothing, then you would say null, right? You would assign null. So there is no room after that. There is no door after that. So this is the declaration of your entire building full of rooms. Now let's see how you initialize it. So this is your room class, right? So each room class, and now you want to call it as a node. Again, I'm slowly translating the realistic example into our programming example. So I'm calling it node. You may call it like a room as well, right? So you may call it a room. And now this you would now instantiate for the first room of 4 walls, and then we are not sure whether that has a next room or not yet, right? So this is the very first room, like very first room, right? So only has one door, right? So this is, with this you are creating address entry to this. So new room, right? New room. So you just initialize this particular one single room. And now what do you want to do inside? So as a game programmer, you want to keep inside room, inside room, you want to have how much money you want to keep in the first one. So say I said 10 units. The second one determines whether you want to have the next room or not. Right? So in this case, we haven't built the next room yet. We haven't built the next room yet. We have built only the first room with this statement. You're getting it? So this is the construction, the instantiation of your actual object, the room object. Now, so to begin with, I assume that the room dot next room is null. This statement makes it that there is no room, there is no door attached to this to get you into the second room. This is the initialization. Now, how do you want it? So let's say you want to build 2 rooms, 3 rooms. Then you repeat this sentence again and again, so it keeps creating new rooms. But what happens if you repeat this sentence with the same variable? The same room gets overridden, right? You are not moving your place and constructing. You are being there and then rebuilding again and again. There is no use. So your intention is to build something just beside the existing room. So how do you combine these two? What is the handler that you have? You have this next room. So you should build, so room dot next room is equals to new room. Now you see this is the key to understand how we reference it. This is the key. Now here in this example, right, so what you are building is you have a room here, you got inside, so this is one door you have built. Now you are inside. From here you want to build, right, so this has one more next room. So next room, think this as another door. So the moment you said the next room, and then you have built another room. So this has a room, its name is room. This door name is room. You get inside, and then here, just with this line now, room dot next room. Room dot next room. Yes, it does exist now. So you can go inside and collect money. Now, if you want to have another room, what you would do now? Right? So because you have reference only to the beginning one, right? Only the starting room, only the first room. So room dot next room gets you here. Now what do you want to build? Room dot next room dot next room. So here you build another room. So you would say, right? So just for a better understanding, room dot next room, this room dot next room got you here. Now you have to go here. So again, dot next room. This is where many people get confused. But I hope you are understanding now what we are referencing it. Right? Again, you call new room. So you just built this now. So room points to the first one, second one, and third one. So you have built 3 rooms here. You see this, right? So the first one, the second one, and the third one. First one, right? Initially when we built, it has no other door. Let me draw it here for easy reference. So the door is here. and here it is null. Null is no door, no next door. This is what you initially built. Then you changed it later. You said room dot next room. So now we are representing this with the same. So this is the beginning, the entry to the room. Room dot next door. You want to assign something. You want to create something. So you created the second one. This is the first one. Then you didn't stop there. You didn't put any money there. You didn't assign any money value here. But you moved on. You created one more. So how do you create one more? You only have the reference to this room dot next room dot next room. Room dot next room dot next room is equal to new room. So you just created the third one. Well, so you keep on doing that. But how long do we go? Room dot next room dot next room dot next room? No, that is not something practical, right? So what do? You could use another variable, right? Another reference to this room object, and you keep moving that. You keep moving that. Okay? So now what? How would I say? How would I represent that? Okay? So here room dot next room is equal to new room. Now I can assign this room dot, right? This room dot next room. Maybe I call that. So room. Always I move the next room, right? So I say temp, for example, right? Temporary. So is equals to, what I would assign is room dot next room. So room is here, dot next room. You are here. So now here you are calling this as temp. Now you could say, so you can replace this third line, right? Third assignment with temp dot next room is equals to new. Now as soon as you have done that, what happened? The third one is created. So we are replacing third one with this. Then how do you create a fourth one? So you have to move this temp, right? So you have to move this temp to here. You have to move this temp to here. So you don't need this here anymore. So now what do you say? Temp is equals to, now the temp is here, right? Temp was here. Existing temp was here. So temp dot next room. Right? So you moved. So initially the temp was here. So since this assignment operation executes from right to left, you are first going to the reference of temp dot next room. So temp dot next room is this. So you are here. You are assigning that to temp. So that variable now comes here. Or for easier representation, you take temp outside, right? This is how we learned pointers. So you learned this pointer was pointing here. Now what you are saying, this temp dot next room, you are assigning it to this. So this reference is gone and this is pointing to this. That's how you keep assigning and you iterate it. You iterate it. You don't need to write 10 nodes for 10 rooms. You don't need to write this sentence for 10 times. So you iterate it. This is how the pointer inside a class takes place. Right? This is how you make use of a pointer inside a class or inside a structure to build a list of nodes. Right? Now you replace the word room with a node. First node, second node, third node. So you are building a list of nodes. And every other node can be referenced using the previous node. This is single linked list. What you have just built is a single linked list using pointers. Right? So I hope you are following me. Now change everything from room to node. So that becomes your single linked list. So I change room declaration, the name to node, right? Next room to next node, and again, so node to small letter node. Everywhere you change room to node. Now you have understood the concept. So now you can get into the technical terminology of linked list. So everywhere you find a room. Easy. So you have created the first node. From first node, how do you go to the second node? Again, node of next, right? Node of next, you'll go. So this is how you get into a single list. Now if you typically go and represent, this is the node, the starting node. right, which we typically call root node. The root node. So this root node has a door, right, in our example. So this door is the next address that will take you. So this one. And here you have some collect money, some variable. You can keep whatever the data you want as per your requirement. And this has created a next node. It's the same copy. It's a copy. So therefore, you are simply saying new room. The structure is same. The node you are going to declare is same. No difference to that. So you're duplicating the copies of rooms. So the room size, the variables inside the room. Again, if you say the furniture inside the room, everything is going to be ditto. A copy of it you are creating. That is a new node. Now you go to next node. And next node. And next node. How many ever you want? You want 10 single linked list nodes? Go on creating. If you want wherever you stop, so the new node anyway, if you put it inside a constructor, the new node will always have null until you assign it. So you stop there. You stop there. So that's how you build a single linked list using pointers. Now let's look into the program next. How we construct a single linked list and then how we traverse. There are various operations, as you know, right? In single linked list, the creation of a single linked list is what we have just seen. You have demystified the understanding of how the pointers are used to create single linked list, to create nodes. Then on single linked list, there are various operations: creation of a single linked list, deletion of a single linked list, traversing the single linked list, right? Finding a loop in a single linked list, deleting a particular node in a single linked list. There's so many operations that come in. Now, once you understand this, everything else is going to be very easy for you. Let's continue.